is we'll have a linear. Okay, in this question, in this exercise, what we're talking about is how many intersections we can find by a linear and like a parabola. Okay, like a straight line and a parabola graph. So how many intersections we can have? Well, if you see the three graphs below here, you can see we have at all like no intersections. There are quite a big difference between each other. Or like we can have touch, just like this is the parabola and this is the line. It's just touch it and exactly touch at one point. In this situation, this line, this linear is called the tangent of this parabola at this point. Let's say the intersection is A, like x value is A, y value is B. We'll say the linear is the tangent at x equals to A of this parabola. Okay, the line is the tangent of the parabola at x equals to A. Yeah, it is a tangent line at that point. Okay, it is a tangent line at that point. Like this is, what's a tangent? Tangent is exactly touch. Okay, it's exactly touch the graph at one point. Okay, at one point. This is the tangent. Well, if it's not only intersects once, it can intersect twice. Well, if it intersects twice, I can have a line looks like this or something like that. They can all intersect like at two different places. Or I can go for something like this. It can also intersect two places. So this is a line that intersects a curve twice is called a secant. Okay, a secant. If it's touched at one point, it is a tangent. And if the line intersects the curve twice, we call that a secant. Okay, a secant. So that's the, can you think about any other case it might intersect 3 times? Or have 0 times, 1 time, and 2 time intersections? Can it intersect 3 times? But anyway, like we change the parabolas and we rotate the line. Can it ever intersect 3 places? Don't think about algebra, just think about the graph. Like, is that possible? No. Okay, it's not possible. It's not possible. Oh, also, like I'll show you why it's impossible. Why, like it can only intersect 2 places at the maximum. Okay, let's think about B first. Okay, let's think about B first. This is a parabola's equation, and this is a linear's equation. Okay, so we have 2 different equations. Now, once to solve for intersection, what we need to do? Like, give you 2 equations without sketching. I want to solve for intersection. What do you need to do? Substitute? Or, well, how we can solve? What's intersection means? They have the same x value and the same y value, right? Yes, Michelle?
You substitute the y into the y on top.
Okay, so you sub the bottom y into the top y? Yeah. Do you mean by that? Okay, y equals to that. I can put sub y here. Okay, I can sub this y here. So just solve them. Because x means the same number, y means the same number. So I can go for 3x plus 7 equals to minus 4x squared minus x and plus 6. How we can solve for this? Like what's the next step you would do? Bring all the x to one side. Okay, so which side you want to move? Left. Okay, so move everything to left. So this term will move to the left for x. It doesn't really matter which side you move. Maybe I want a positive x squared, so that's why I move it to the left. This x will plus with 4x plus the 3x with the 4x. And then we minus 6 on both sides. I will have a plus 1, and that equals to 0. All right. This is the place show us y is not going to intersect 3 times. On this side is a linear. On this side is a quadratic. And when you move it to the other side, you will have a quadratic as well, right? You're not going to have anything else. You still have a quadratic because the x term combined with the x term, the constant combined with the constant, and you still have the square term there. Like, still have the square term stay there. So you will have a quadratic equals to 0. There's only 3 cases you have quadratic equals to 0. There's only no intersection, like no solution. Okay, I'm not solving for a point yet. I'm solving for x value. I can have no solution, 1 solution for a quadratic, or 2 solutions for a quadratic. Because you sub one y into the other one, you have a linear equals to a quadratic, and you will move one side to the other. The x term combined, the constant term combined, you're still left with a quadratic. So overall, you are trying to solve for a quadratic equation. And there's only 3 situations for quadratic equation. I can only solve out no solution, 1 solution, or 2 solutions. There's no case we can solve 3 solutions out. So therefore, that's why we will never have 3 intersections. How many solutions I can solve out here? How many point of intersections we will have? Is that right? Yes? Okay, this is important. Okay, we will need this later. How many solutions I can solve here? How many point of intersections we'll have? Okay, remember that because we'll use this fact later to solve out something else. So we equalize the 2 equations, simplify it, move it to one side. We will have a quadratic equation equals to 0. Then how many solutions we can solve out here, which means how many intersections we'll have overall for this 2 graph. Okay, so for this, how we can factorize this? How we can factorize that? Breathful? It's a perfect square. Have a look. It's a perfect square. 2x plus 1 squared. Okay, so you only can work out one value, right? Like it's minus half. Okay, really important question. Without doing this step, okay, without doing this step, without showing 2x plus 1, without factorizing that, if I want to tell how many solutions I can work out for this equation, what's the other way you can do without factorizing? A quick way, like a quick way. I don't need what is the answer. I just want to know how many solutions we'll have. Discriminant. Discriminant is 4 squared minus 4 times 4 times 1, like b squared minus 4ac. So it's 4 squared minus 4 times 4 times 1. Discriminant equals to 0 in this case. Therefore, we will only have 1 solution in this case. And then my factorize shows that there's only 1 solution as well. Okay, so if I'm not interested in what is the x-intercept or like the intersections, but like if I'm not interested in what is the intersection, I just want to know how many intersections I will have. You can just do discriminant after this step. Okay, after this step. Let's just write what steps we have done. Right, we want the red color. So step number 1 is equalize both equations. Okay, so it's a linear equals to a quadratic. Okay, in terms of x. In terms of x. Second, move everything to one side. Well, it doesn't matter left hand side or right hand side, just move it to one side. We will have a quadratic equals to x, equals to 0. Okay, we move everything to one side, you will have a quadratic equals to 0. Okay, I can go 2 more steps from here. I can go for 3i. Okay, I can go 3i. Check discriminant. Discriminant less than 0. You will make the conclusion that there's no intersection. If discriminant equals to 0, you will make conclusion that there's y intersection. Intersection. Discriminant greater than 0, there will be 2 intersections. This is when you're asking for the number of solutions. Okay, just ask you how many solutions do you have. I can't tell what's this, like the solutions, what's the solutions yet. But you can do 3i, okay, factorize. Well, you can do factorize equals to 0, or you can use quadratic formula. Okay, what we can do, quadratic formula, or you can use completing square. Okay, they are all the methods you can solve for a quadratic equation. Yeah, they are all the methods you can solve for a quadratic equation. You can factorize it, that's the easiest way. If you can cross multiply, factorize, I can make every bracket equals to 0, solve for x. Or I can use quadratic formula directly, minus b plus minus square root of discriminant over 2a to work out the x values. And or I can use completing square. All of this will give me the x value of intersection. The x value of intersection. Well, it's not the coordinates yet. So, for example, up to here, I have worked out the x value of intersection is -1/2. How I should work out the y value? Sub in. Which one I will sub in? Can I sub into the first one? Yes. Okay, I can sub in the first one as well. I can sub in at a equation, but sub in the second one is obviously easier to calculate. So most of the time, I will sub into the second one directly because it's easy for me to do the calculation. So step number 4, I'll write here. Step number 4. Sub x value into the linear to work out y value. Okay, sub x into the linear to work out the y value. So what I should have, y equals to 3 times -1/2, 3x plus 7. Y equals to -3/2 plus 14/2. Y equals to 11/2. only one intersection, which is -1/2, 11/2. Y equals to 3x plus 7 is the tangent of y equals to minus 4x squared minus x plus 6. Plus 7, I think. Wait, plus what? Plus 6. Okay, so because there's only one intersection, if there's only one intersection, which means the linear is the tangent for that quadratic. Okay, is the linear of that quadratic. Well, if in some case like D, if you look at D, well, I can only sub y, the top one, into here. Okay, I can sub the top one into that and then solve for that. So basically it's a simplification or elimination. So you can choose any method. Okay, just solve for simultaneous equations. This is not the hard part. Okay, so the important thing is remember your step, and then 3i is the most important part. Let's talk about the number of solutions you have. Let's talk about the number of solutions you have. If you go to the next page, let's look at the next question here. Determine for what value of k. Okay, this is the type of question we like to ask. We not always give you a fixed quadratic and a fixed linear, and then you solve for it. That's not really fun. Okay, so what we'll do is we have 2x plus 1. Okay, we have 2x plus 1. That's a linear. Okay, if you think about 2x plus 1, when 2x plus k, if you think about k equals to 0, I will have y equals to 2x, right? Y equals to 2x. Y equals to 2x looks like this. Do you know what's the k doing? Like, what's the k value? Like, if k is 1, what will happen to this linear? Move up. Okay, k is 5. Further up, right? But they are all parallel to each other. They're all parallel to each other. So you just keep moving up and down. Like, the k is keep moving this linear up and down. Okay, we have x squared plus 3. Okay, x squared plus 3. Well, x squared plus 3, well, 3 should be here. That's something already we know. There might be another intersection like that way. Can you see that? Because there's one intersection already, and this is not the tangent. You can see it is not the tangent. So there must be another intersection like over there, okay, that way. So now I want to ask you, determine for which value of k this will intersect with this quadratic. Okay, this line will intersect with this parabola. So let's think about when it won't intersect. Well, if I draw a parallel line, but here there's no intersection. Oh, this is not really parallel. Okay, there's no intersection, right? But if I keep moving up, there will have intersection. Okay, there will have intersection. So the first point, if I say moving up, the first point, this linear will touch with this quadratic, like the parabola graph, will be this tangent here. Can you see that? That's where they start intersects between each other. And then if you keep moving up, they always have intersections if you're just moving up, because the parabolas keep going up. So you keep going up, they always have intersections at the top. But the first place they intersect is this green color here. Like, that's when they first intersect between each other. So any k value between this particular k will work. Okay, like above this k will be fine. So what we should do, well, this is an explanation on what's going on here. So if we think about, we do first step, equalize them. 2x plus k, I don't know what's the k, but k is a number, I know it's a value, equals to x squared plus 3. Okay, I can move everything to this side. I can say this side is 0. This side is x squared minus 2x plus 3 minus k. You can move everything to that side. You can move everything to one side. Well, which side I will move? I want to keep the x squared become positive. I want to keep a positive x squared. Alright, there's only 3 terms. Okay, remember, you can see 4 terms. I know you can see 4 terms. But overall, for a quadratic equation, is ax squared plus bx plus c. Okay, ax squared term, x term, and the constant term. So what I can write is x squared is the x squared term. The minus 2x is the x term, the thing with x. Then the last term will be this. That's the constant term because k is a number. For example, k is minus 1, then overall this term will be a 4. If k is a 5, then it's a minus 2. So it's a value, like it's something together. It's something together. It's one thing. So I want to have intersection. I need intersection. So I need to solve out something from here. In which case I can have solutions for this quadratic. If you think about discriminant, what happens to the discriminant? Discriminant should be what? Then I can solve out solutions. Can discriminant negative? Then what needs to be? Discriminant needs to be what 0? Greater or equals to 0. Okay? So discriminant needs to be greater or equals to 0. Greater than 0, I can solve out 2 solutions, which is good. Equals to 0, I can still solve out 1. That's good as well. I just need the discriminant not less than 0. Okay, not less than 0. So discriminant needs to be greater or equals to 0 in order to have solution. Solution or solutions. So what I will do is minus 2 squared minus 4 times 1 times 3 minus k, and that equals to 0. Okay, that's the discriminant. That's C. Okay, so what's A? A is 1. B is minus 2. C is 3 minus k, because 3 minus k is a number. Okay, C is 3 minus k. So I have 4 minus 4 times 3 minus k equals to 0. Should have 4 equals to 4, 3 minus k. 1 equals to 3 minus k. K is 2. Well, I need greater or equals to. So greater or equals to. What I have is move k to the side, k greater or equals to 2. My graph is not to scale, so this one I think is a little bit lower. So if I move that. Move that to higher place. Okay, so k is greater or equals to 2 because I need. If I just talk about number of, if you move k to the left, Okay, if you leave k on the right, then k is a negative k. You need to divide k, then sign will swap. Divide negative 1, then sign swap. You still have greater. Okay, let's look at the next one. The line y equals to mx is a tangent to the parabola y equals to x squared minus 2x plus 4. Okay, if m is a changing value, how, like, different, what is doing? For this one, for example, I'm changing k. The linear is moving up and down. Okay, it's moving up and down. Like, what kind of change you have when you change the value of m? M is called what? M is what? Gradient. When you change your gradient, what your graph might do? What's the y-intercept in this question? What's the y-intersection? Y-intercepts. Y-intercept. No, for this graph. That graph. 0, 0. Okay, 0, 0. We can have 0, 0. Different m is a rotation. Okay, it's a rotation. And all your point will intersect here. So this can be one value, this can be one. You can have one like this, you can have one like this, you can have one like this. It's just a rotation. Okay, it's just a rotation. That's the y, that's the x. So we have this quadratic here. Okay, something like this. Something like this, okay. I can draw one of this. Okay. So the pink one is my quadratic graph, and then all of this is rotating. Okay, rotating, and then they can intersect. They can be far away. For example, this line is just get far away. You see that? Like not intersects at all. But like this point, I use another color. This line is the tangent where they start touching the function. Like that's the tangent of the quadratic. Well, I can find another tangent. That's not really tangent. Well, I can find another tangent on this side. Right? Do you agree? You can have two tangents, like from this side and this side. When I sketch it, it's not necessary to be accurate, okay? It might not be accurate, but I just can sketch something similar to that. I probably have two tangent values, two tangent lines, okay? So it's rotating different m, okay? It's rotating different m. Now, if we think about that, find the possible values of m. If the linear is a tangent of the quadratic, how many intersections do you think you have? One, right? In between the line and the quadratic, there are only one intersections. So I will make x squared minus 2x minus 4 equals to mx. Okay, always equalize them. Okay, always equalize them. Okay, yes? Oh, yes, thank you. Plus 4. Okay, and then I can move everything to one side. I probably need to move it to this side because I want to keep the x positive. But this is a little bit complex compared to the previous case. I said there's only 3 terms. Okay, there's only 3 terms. The x squared term, ax squared term, bx term, and the c value, like the constant. Last time, like the k belongs to the constant part, right? It's combined with the 3. Okay, what you should combine for this m in this case? Is that x term, x squared term, or constant term? X term. So you need to put it together with the x, okay, with the x. So we have x squared. Now what I may have is minus m plus 2x. Okay, you take common factor minus x. Minus x is your common factor. So you have m plus 2 left in the bracket, and then plus 4, and that equals to 0. What discriminant do you need for this time? 0. Yes, 0. Discriminant should be 0 in this case because it is the tangent. Okay, it is those two, like these 2 lines, one of these 2 lines. So I will have minus m plus 2 squared. That's the b squared, right? Like I will write a equals to 1. B equals to minus m plus 2, well there's a bracket, and c equals to 4. That's the a, b, c values. So minus 4 times a times c. That equals to 0. For the minus squared, you will have a positive squared. And that's a minus 4 squared equals to 0. M plus 2, well, because the minus 1 squared is still positive 1, so it's just m plus 2 squared. It's same as there's difference or no difference between negative or no negative. So I will have m plus 2 plus 4, m plus 2 minus 4 equals to 0. I don't want to extend it first because I can use the difference of perfect square to factorize it directly. So m equals to negative 6 and m equals to positive 2 in this case. Okay, let's label that on the graph I sketch. This line is y equals to 2x. Okay, positive, like y equals to 2x. And the other m I solve out is y equals to minus 6x. Okay, this is the minus 6x case. Well, it might not be exactly right, but exactly accurate, but like that's the 2 lines, one negative and one positive. Okay, that's the 2 m values. Can make the linear become the tangent of that quadratic. Do we have any questions so far? Let's understand how it becomes the tangent, and then we can work on the next 2. Next 2 is really advanced things. Okay, it's really advanced things, what we should do. Can you explain why there are 2 possible values of m? Well, I have explained it. One is the tangent of the right-hand side, and one is the tangent of the left-hand side. Diagram may help, so that's what I can do. Like, it can be intersection. It can be the tangent at 2 different places. Okay, at 2 different places. One on the left, one on the right. For C, if the value of m is changed, so that the line now intersects the parabola in 2 places. Okay, not only intersects 1 place, intersects at 2 places. What is the set of possible values of m? Okay, what value of m are possible? There's not only 1 m or 2 m possible, because you can see any line in between these 2 lines will intersect 2 places. Can you see that? Like, if I rotate it this way, there can be two intersections. But if I'm rotating this way, there will be no intersections between the quadratic. See, if it's this line, there's no intersections. If it's this line, there's no intersections. So it must be the gradient in between those 2 points, right? Like in between that. So the something in between that. Let's just have a think. Okay, I just draw another one. Just draw another line inside here. Okay, this line will intersect as well. Okay. All right, let's have a look at this one. This green line here. If this yellow one is 2x, can you give me any possible value, any possible equations for the green one? Like any value. Is that like it's going this way? Is that the gradient become larger or smaller compared to the 2? The gradient is 2 here. So if I rotate this way, like for this green line, it's still positive gradient. Is that the gradient become really small, really large? It's more steep or more, is that steep or this one compared to this one, is that more steep or more flat? Steep. Steep. This is called flat. Do you know linear? This is really flat, 0. Gentle, and then steep, steeper, even steep, very steep. Yes? If that's 2, that can be 5, or can be 4, can be 3, can be 2.1, can be anything gradient larger than this, but positive. So you can keep increasing your gradient. Can you see that? I can keep increasing my gradient. I can always intersect. Like it extended that way, I can intersect. Well, can't really reach a vertical. You don't have a vertical linear, like there's no gradient for vertical. So you can have anything just greater than 2. Okay, anything M can be greater than 2, there will be 2 intersections. That's for the positive side. If you think about rotating this way, there will be 1, 2, 2, like greater than, but only this stop here, like you can't have this, you don't have this. So a little bit that way. Okay, so still have 2 intersections, but the really large gradient, because it's really steep in this way now. Okay, this is flat, and then steeper, 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 and then it's like a vertical one. We don't have a vertical one, so we don't have M for a vertical line. So anything greater than 2 will be fine. Okay, let's think about this side. If this is -6, negative what this can be? 7, 8, and then go inside. -10, 20. I can keep going in. Well, I can intersect until reach a negative. Like this is a really like -10,000 something, like really steep -1. So I can keep reducing the value from -6. So, and M can be less than -6 as well. It's negative value, right? I can have -6. Well, you can see -7 might work. -8 can work. -10,000 can work. So anything less than -6 might work. Okay, so it's M greater than 2 and M less than, like, or I can say or, like this I should say or, like any value in between this range. Okay, M more than 2 or M less than -6. So 8 can work. Can 1 work? No. Okay, 1 doesn't work. Can -5 work? No. Okay, -5 can't work. So it's anything on this two set. Okay, anything on these two sets. So less than -6 and more than +2, that you will have two intersections. Why I use a graph? Because you haven't learned how to solve quadratic inequalities, so I can't really show you the proper algebraic way to do it. You can, from C, you can solve discriminant greater than 0. Okay, you can solve for that. You can solve discriminant greater than 0, but like you haven't learned how to solve quadratic inequality yet, so it's hard to do this. So I will just show you the graph and reasoning why like m should be in between -6, less than -6 and greater than +2 from the diagram. Any questions? You probably won't have this hard questions like in your test, but you will definitely have what k value can make y intersection, what m value can make a tangent. You will definitely have those questions, but not like the greater, less than, like C. You won't have C, but for A, B, you will definitely have that. Any other questions? If you don't have questions, use the rest of 15 minutes to work on A, C, and D to find the coordinates of the intersections.